Okay, this is not going to be an easy one to walk you through, but we're going to go through it, and then we'll stack it from there. All right, request-wise, please watch the commercials for me. That way it gives me some algorithm boost, I think. So I know they're not fun. Also comment, it is kind of funny how, how the commercials are kind of odd. Everyone tells me things like, hey, look, I really do use a deodorant, but they keep pushing this deodorant at me, like that person that said that. I thought that was funny. Or another one said they're pushing booze on me. I'd like to see the booze commercial. Look at this video down here I have called Champlain Towers Collapse, Pool Deck Concrete Core Samples Failed. Deck very obvious in core samples. All right, here are your samples. This is B5. As we go to 8, and Tom, I wanted to give a shout out to you on something here. Let me jump right into the repairs. Look at my notes here also. I got a few pages to hit on. So let's look at this deck repair. This says pool slab full depth repair. So that deck had some major issues with it. I talked about that in the video, and I don't know if that video or another one. But this shows it was failing in the middle. Now, I think what happened was, using all the witness statement now, specifically the Nayers, the 111 people, that I think that when she heard collapse, when she heard the floor fall down above or wall fall down, and the daughter said the same thing, I think what happened was part of the deck in the garage had an initial drop, and then a stop. And that stage that stopped went all the way over to the building and shook their building. Now she goes to at that point she doesn't look out the window. She doesn't look out the door, right? She goes to the office. She walks down the hall to complain about noise. And then she hears a loud bang from the garage. I think that's the secondary, the final equilibrium, becoming equilibrium at that point. It breaks free totally and collapses down, and it does a secondary breaks all the way back to the building again. And I'll get you to the building there, to the beam. Let me do that biasly now. So 24. I should go to page 11. Well, before I do that, I want to show you these are full deck repairs. I want to show you something else that's kind of a ridiculous statement on here. Let me back up. Not on my part. I make a lot of those, but not right now. So I come up a little bit. Look at my notes here. I think at page 11, but I think there's something up here real close, or it might have been down below. Let me just push on through this to page 11. Then we'll come back to page 2, 3. Yeah, let's push on through this. Trust me on it. And bear with me. So that's a slab drop right there. See, topping slab pavers at storefront at slab drop right there. And slab drop again. And your BMAs, of course we know them, they're beam style A, right? But BMAs are the quick way to get to it. Just say BMA, just do the abbreviation. You don't have to say beam A, just BMA. For the triggered people out there, you'll get over it. All right, so I'm on page 15 now. I want you to think about punk shear protection, about critical shear zones. Well, this is a BMA right here. This is the beam A. This is the BMA right here. And look what they're doing here at a BMA. This says gravity epoxy full thick crack. A full thick crack. You know what that means? That means this concrete has pulled away in the rebar engagement, as we talk about it in a very light manner. We have some pull-out going on here. To get pull-out, we have to have deflection. We have to have loss of stiffity. Stiffity to get pull-out. You got loss of stiffity. Yes, I said stiffity. All right, so this will be the deck. And And so here's our non-breaking part on this side of this BMA. So let's do that. And on this side, let's do this. I'm going to do a couple of them. I think I'll do that one like that. Okay, so that's the concrete, this capacity. Now watch what happens when I put... Really? You're acting together now? Oh, right. Because I turned it, I made a square. It thinks I wanted to make a square. Delete. All right, so here's our beam. Here's our concrete. Right in here is that crack. So I'll give you a little piece of concrete right there. All right, we can push that up. So, thanks, Bruce. So there's the crack. How do we get that apart from each other? Well, what happened was they decided to stretch. Like, oh, it stretched apart, right? Oh, okay. So this stretches apart. What happens? This beam, this BMA has to push somewhere. It has to go with it, right? So bear with me being facetious, guys. I hope you understand I'm being facetious now. Oh, wait a minute. That could just shear across the top of this BMA. Oh, so they got to move together. Oh, yeah. Oh, wait a minute. Not for free. There's a wall here. Not for free. So, oh, whoops. It runs into the wall and knocks the wall over. It doesn't present that way. But what it presents as this. Let's go back to that crack. Let's move this out of the way. So here we have, let's look at it in the capacity. This is amazing, the title of this one called, this is a non-structural crack over here, titled over here. This says partial thickness non-structural crack. It looks friggin' huge. To get that, you would do the same thing to get this one. To get this full crack, you're looking at a hinged deck. You're looking at deflection in a deck like this. This deck deflected, and I'm exaggerating to get you there, but this gets you there. This is really. I want to grab this little guy. This gets you there. This is my exaggeration crack. All right, that's opening. That's going to be higher, thicker here, tighter here because this is compressive down here. It's going to want to hit that, but that's the exaggeration version of it. All right, so. This is at what? A critical shear area, isn't it? Because it's right above. This is connected at a column, and that one's connected at a column. They just ran a deck and then put this like upside down strong back in there. This is connected at a column. And this crack represents deflection and the deck. The deck over on this side. Oh, wait a minute. We got a crack over here. That crack represents deflection in the deck over here, like this. And when it falls down, this stays here, thereupon connected to the column here, and we get this opening. There's a compressive moment in here, but it took it to the point where it didn't fracture all the way through, and it went that far. Now, there's a load between the two. This is carrying a load. This BMA rather, it's going across, right? Remember the BMAs look like something like this, right? So there's a BMA. This one here would be this one. Well, if we could look at it sideways like this, and let's put a column going down. Let's do that. And there's a column over here also. We would look at it at the end of it. We would see this fracture. And this fracture is somewhere in there representing that this deflection, that this is deflecting, again, creating the tension in the steel, tension in the concrete, and it's reacting right there, showing a full crack. He's showing both sides. Both sides. That's fully developed all the way through with this type of detail here. I don't know how long it is, but it's showing. And look, here's a secondary one down here where it wants to come apart. Now this is going to add up. It's going to add up real fast for you if I get to page 13. If this is the right 13 document. So there it is again. This is around your, right around, this one's kind of shallow near the top, but nevertheless it's still It's an cantilever past there. It's again by your BMAs. Your BMAs, right? It's by your BMAs. So your BMAs. Now, here's a problem I'm having. It actually says it's by. We go to page 11. Let's move on. I'm still working on that. So now we come over here, page 12. Here is our KLM. Here's M, a K, L, and M. Right about here, we're going to see on the next reveal coming up, page 11. Better be just page 11. Previous video. But lo and behold, we're right here by the stamped concrete. Where's the stamped concrete? In the garage area, in the driveway area. Sampling there. Now he's doing his own test. He's doing his own. He's working by himself. He did this, and over here is like a Bosch laser. I know I've got. I think I have the similar laser. One of them, also. So that's why he probably has the board up so he can spot the dot and do his elevations. However, he's figured out his elevations. But this appears to be by that planter. There's your ballard. This is right in front of. Planter by the driveway, and he just blocked it off. Okay, so welcome back to D4, etc. These are the samples. This shows you this deck. You know, all these people talking about they running programs, and let's just bash on them. Josh said I ran a calculations and it wouldn't. Look, we're looking at it right now. Right now. So stop with the calculations bullshit, smoke and mirrors, trash, lie talk. You didn't run any calculations on this. No one has. Can run calculation on this. You look at this and you call it broken. When you start testing samples, as soon as it fractures, whether it comes off the top a little bit or cracks all the way down, the sample is done. It's considered failed at that point. So if you were to start compressing this and you get a slight fracture right here, it's done. If it happened at 1,200 pounds, it's done. Even though you may think you have all the material left, it's already failed. This has failed in multiple times. 1, 2, 3. This presents as steel right here. So there's a layer of steel there. That would put it at what? That's 1 inch. That's 9 inches. About 8 inches apart. And so it puts it high and low again, as we know. About 1. Hey, girl. About 1 inch apart. And then we have this is D1, D2, D3, D4. The way he broke it up. He had to number them. She or he had to number them so to remember how they came out of the damn hole. You normally can number one sample. This one came out. Look where we are by the flower box, I think. This one came out, went through the steel there, and look at this thing. Well, he did take a piece of steel out. That's interesting, right? That is interesting. Remember, I got to get fractures through M, and I'll get us through M. You'll see. But look at this thing. It's multiple layers. It's like each one's a sheet of paper, one piece of plywood. Imagine if you took the layers apart and you stepped on it, they would just bypass each other. 1, 2, 3, 4, and that might even be 5. So that's what I'm showing you there is that these are, you know, everybody, all these engineers saying they did calculations on the deck are just full of shit. They're full of shit. They did no calculations on this deck. None. This is what the deck presents as. This is the deck. It presents as a failed piece of material decking done. Now, I'm just trying to think if you rolled it over. No, that looks like it's a separate. I'm looking at the scale. Yeah, this is another piece. This is another piece. They're both about 13 inches. I don't see this, even if you rolled it, I don't see this piece being over here or there. This piece is too long. This is a 4-inch piece. I see no 4-inch pieces down here. So these are two samples. Both samples came showing back this deck has got all types of fractures and lateral movement from, say, here to here. And maybe this is the cover, the pool deck area with the, maybe drill right through the pool deck, I don't know. But this one is pretty damn trashed also. I mean, it's just trashed. There's that one piece of steel there. Now, let me find that damn 13 for you. Core sample A. Mr. A comes right down by column M. Mr. A is column M. right in front of the planter box, which is right in front of there. This is our shit deck. The core sample came out of there. We're looking at the planter box area, the tiles, pavers, whatever you guys want to call them, whatever you're triggered by. Listen, everybody that's triggered by, I'm tired of you guys also. You don't understand, do not contact me, what that means. I see you signing back in and doing your childish comments, and you just made a new account literally today. A couple of you did, or one of you did, or you're doing the same thing over and over. Really, go away. Go play with the other people. Go play with the children. Go away from me. Go away from me. You can bet I've already reported you as a false account and harassment. Now, you're a new account, and of course they'll be able to tie you back to your old account. You're an asshole. Go away, people. Stop coming back here. I don't have anything for you. Go watch the Tool Jack Off guy. Jeff Off, whatever his name is. And what's his name? But look, so that's too far back. Well, let's come here. Here's the parking garage. The parking garage where we have the shear plane failure, right about here, shows that deck was shit. There's a dissection of it before the collapse. We're looking at it. It's shit. There is no calculation that Josh can run. There's no calculation that any of those other engineers you guys send me links to can run. If they run it, you're being lied to, deceived. It's broken up. There is no calculation for this. Anybody who does testing will tell you that this is a failed sample. Whatever it came out at is whatever it came out as. Now they can take each one of these pieces and fracture each one individually, but as soon as it moves a little piece off of it, it's done. The sample's done. It's considered failed. It would be interesting to do that to see how each one would behave. That would be very, very interesting. Incidentally, there's a report attached to this about these. I can't find a report. Tom and I tried to play around with it. I called Tom up and we talked and said, Tom, can you find a report? He couldn't find it either. We couldn't find a report on what they finally said about this. And maybe we're looking at it right now. Maybe this is the extent of it. But you're looking at right here, RM. Test probe. Approximate section line. Huh? 1 foot 6 elevation. What? What we got going on here? So they took a piece of steel out. Noted 5 NA approximate relocation. Five and 8. So they did extra pads, right? The exploratory pads. They asked to do extra, and so this would be core B. So 5 and 8. Note 5 and 8. Where'd you go? They asked for extra samples. That's a soffit. So the soffit is not really, that's a soffit area. So that's not really my concern, but let's back up again. We got it through M, baby. This is the end of the video. This is all I wanted to get you guys, is I got us to M. I got us to M. I have us on these BMHs. BMAs are in a failed capacity, that that they need, some of them are full are failing, fractured. They need full support. So let's get you that full support thing before I go off. Go on. Let me look to the left. I don't know if this is the document. I think this might be it. Let me just scroll real fast to the left. Sorry, guys, I'm crossing my legs. Let me scroll to the left real quick. I'm not worried about minor things like this, or that little bit of that cracking. Water coming through shows you that it's deflected again. The epoxy would have closed it up. If water's still coming through, either he didn't fully epoxy it, or it deflected again and the epoxy failed. Well, the epoxy didn't fail. The installer. The marriage failed. How's that? Come on, baby. Right, that's the pool stuff. The thumbnail's to the left, that's just pool stuff. Okay, so I pull this down. We'll be able to pull this one back up. Ooh. Yeah. Yep. So right here is where the repairs are supposed to be. All of them coming out to this S2C-2.3. The repairs, they basically tear off the deck and go from there. Have you all of this junk, everything there, all of it, just off, just OFF, right? So that's page 11. What did I have here? I said page 15 for some reason. I think we did 15 already. Let's see. 15 says puncturing, right? Oh yeah. So here's this deck failing where it comes up to that BMA. So it comes up to that BMA, which we know to be page 35, right? So it comes up to there, and I'm guessing it is. Come on, page. So I'm going to zoom in a little bit. Zoom in again. I'm going to shift this over. So this is what I think is the fractured one, this one, or it could be this long one here, or this long one here, or this one. Now, I'm going to show you support of two of these parallel to each other. So it's either supporting this one and repairing this one, I think was going on. So support this one and this one. Why they repair this one? It's an odd duck on repairs. And that would look like, we go back to our repairs. There's a lot of puncturing issues going on, a lot of, right here going up to a BMA. So that's going up to a BMA. You support the floor before it. And then you take out this section, not cut out, you break it apart, jackhammer it, whatever, you follow the notes. You put the more reinforcement at the top, you close it up. That helps get this deck tied into this BMA, transferring the loads down the columns. One of these BMAs has the fracture all the way through, though. It's already, so page 15, right here. This BMA, this one that's loaded, I'm going to be impartial and I'm going to be quite biased. Okay, I'll just tell you straight up. I'm going to be quite biased and say that's probably our M. So as this deck collapsed, it probably hit that weak ass one right here, because you remember this is tied in. I want to do this release differently, but this is multiple decks. See, this goes up to here, and then this is another deck up here, 12'9", and there's reinforcement inside there, so it's not solid filled concrete, at least not per the drawings. It's another mini deck that goes up, and then you have a 7-inch step into the property. So it's a deck over to this BMA, beam A for you sensitive folks, and then this BMA as it stays there, and then it goes up an additional 1 foot 11 inches, and I think that would have been changed to probably 1 foot because of the elevation change by 1 foot here. So they would deduct 1 foot from here. So again, we lose our BMA sizing to help support this decking, but it's pretty close there. But nevertheless, it's the end. It's where the deck connects there. It connects here. It then goes to the porch here, which is at 12'9". All the way over to here is 12'9". This is another deck, 7 foot out, but at the same elevation. You can see the rebar, why I call it another deck, because the reinforcement is hook shaped. It stops. It doesn't cross over. They wanted it to come to the BMA and be installed on top of it as such. Now, can I get us to the BMA image-wise? Oh, this is the clown I'm talking about. They came back. Just signed up today, came back and started harassing me. You know what? I'm going to see you every time out, and you're getting blocked. You people are so obvious. That's the clown. He's already been blocked. So he gets the clown block. He's not even worth the PayPal because he's somebody that somebody who harasses you. So he can just bite dick, go away. You know. So what do we have here? So this is the many pages, right? Let me scroll back up here again and get us back to that beautiful point in this one. Looking to the pages to the left. And look at my notes now. So top of slab, right? Test. Right. So you saw it was in front of them. Yeah, where is it? So you saw it was in front of our M, our defects. So we're at M now. We're at M with a deck that's willing to separate and shear and everything. Now, that's what it was. I want to play the mama bear again. I want to play her content again. Really? Really? I'm trying to find that same page again. Let's do this. Here it is. This is what I'm looking for. So I think now that we have possibly this area right here, let's do this. Let me give you a profile of it when I do it. So I think we have the deck initially getting some puncture down and over a slight bit, maybe even over to there. Oops. So from here, right? So it would be all this area. Delete. Let's do it again. So let's do this and let's turn. Let's go towards the pool. Let's turn and let's go at the expansion joint. Look at that amazing where the dots are lining up with the expansion joint. Isn't that friggin' amazing? So I think that they had initial bump was this dropping down, so a slight drop. Maybe 2 inches. Let's call it 2 inches, right? Nothing for free. Nothing for free. That's 2 inches. It tugged on the structure, and it caused the shaking above them, and it made one of the walls, the internal walls, the block walls, possibly fall over, and that's when she went to the lobby to complain. This did not fall down all the way through yet. It was able to find equilibrium grabbing again, and held on for a moment. While she's making the complaint, this accelerated creep, real accelerated, this part, boom, dropped down over to, I'm not going to go that far yet, to there. He does his observation, Joe Friendly, whatever his name is, the son, does his observation from the porch, as he states. He then goes to the door. The mom starts running back after that. She runs back, not through this way, but apparently through the hallway. She runs back. We got to leave. They meet her at the door, apparently, or thereabouts. And they go to the exit. Mom says the story about how she had to get them to leave. So let's get that audio up again. That video. So I might have to go to comments to find it, or I might find it right here under a replay. So it's on the nope. Yes, here it is. So let's replay this and let's give it a narrative.
In all the heartache here, for all the questions that may never have answers, and for everything we've yet to learn, there is this, and we couldn't be happier to bring it to you. A mother and her 2 children are safe tonight, and they might not have been. Sarah Neer was at home not long before the tower fell. Like,
I heard a couple say you don't like her smiling. She's a kid, She doesn't get the gravity of it.
Before the tower fell.
And that's a pun on words because you guys know I believe in equilibrium.
Along with her daughter, Hani, one of the 2 children who were there. Thank you both so much for being with us. Sarah, I want people to understand.
I call it inappropriate laughter. It's not, I don't think she's laughing. She doesn't get the gravity of it. Many people died, and she's smiling, happy to be on news. Or she does, and she's a baby narcissist. We'll find out.
How close this really was. It was late, or early in the morning, 12:30, 12:40 in the morning. You were doing emails and then you heard a sound. What happened?
Exactly. I just came from a party, like spiritual party was, and it was 12:30, and it was a little bit noisy. My son and my daughter being around me, so I didn't pay attention to the surrounding. It was so about.
So we know at 12:30 nothing collapsed, right? She came in the building.
12:45, she went to take a shower.
So 15 minutes later, still good.
And my son was
12:45.
busy, so suddenly it was quiet. I was sitting and
Remember, suddenly it was quiet around 12:45. Quiet.
checking my emails and my messages, and then I start to hear knocking sounds, knock, knock, knock here and knock, knock. And I said, okay, somebody probably hanging pictures on the wall. And then it was more intense. And I said, oh, probably they're doing some small renovation. And then suddenly around 1:10, I hear like a smash. The wall is collapsing. The wall above me.
So this is the part that, see, the knock part I can get is even a washing machine above her having the tumble, the clothes in the wrong side. And that thing will bang on that side of the drum pretty hard. Bang, 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 bang. That would give you a knocking sound. But she stays at a wall, like a wall falls down. So that's why I have to add this other step right here where I'm stating that possibly that we had a primary, the initial break, which tugged back over to M, and she's over here, tugs on M, and causes one of the walls to flex a little bit. That gives that lady time to get out. Remember 611? So 611, because if I don't do that, and we now know what we know based on timeline, I would only have the lady upstairs having 4 minutes to exit, and she puts out candles and things like that. Remember, she also says she was able to put approximately two fingers in the wall gap. The way she points it is kind of weird, off to the side, so I'm really confused. And also saying she's using candles, so does that mean she had the lighting on? Was this just candle light? So, she leaves because of that vibration up there. So I think that what she heard, the banging, that vibration is possibly already taken place at this point, up to the wall. And then she goes out to the lobby to complain to the guy. She says guy multiple times. So she doesn't recognize the security guard, the lady security guard, as a lady. She thinks it's a guy.
I said, wow, they're really doing major construction. I need to take care of this problem. It was already 1:10 in the morning, so it doesn't make sense. So I ran to the security guy that I live in the ground floor. So
not guard, she is saying guy. You'll hear it in a bit. It's guy.
It's first floor. So it's really a wall separated between my apartment to the security guy. And I ran to him and I said,
went to him and I said,
hear this sound? It doesn't make sense in the middle of the night, early morning, people doing construction. So he said, yeah, I hear this.
He said, yes.
It's also noises. So I said, so what do you do about that? The minute I said, what do you do about, then it was a big boom.
So that's the big boom. She's in the lobby at this point. She's going to walk down the lobby and see the cars crashed.
And I was running to see where the sound comes from. And I saw all the garage collapse.
So remember, the security guard said it was the elevator. But clearly she was participating also. And she had no problem going beyond the elevators and looking into the lobby area out this window here and noticed the cars collapsed. She says all the cars collapsed, right?
I couldn't believe it. I thought I'm in a movie. I look again and I ran back to the hallway and I saw my two kids.
And I ran back to the hallway and I saw my two kids. See, they were at the hallway at that point. But remember, he tells a story that he's the hero, but we'll move on. We'll just accept her story, and we, quite frankly, we don't really need his story anymore. He's adjusted his story since the Twitter one, but we don't need it. It's nice, but her story is more solid because I don't like how, I know that you guys can, we know about stress and everything else, but at one point you now made yourself the hero in that. How come you didn't make yourself as my mom? You didn't remember your mom sing in the hallway and come out? She's not disputing it.
I look again and I ran back to the hallway. And I saw my two kids standing next to the door.
I saw the two kids standing next to the door. Remember? And he's like, he tells the story. I told him we got to get out of here. And really? So apparently his amygdala won't allow him to play second fiddle to this incident.
The entrance of my apartment and don't move.
And they don't move, right? See, they were shocked. That's what I remember. That's how I reported it before I realized it was him. They're shocked. They're in shock, you know.
Standing next to the door, the entrance of my apartment, and don't move. And I was screaming, it's an earthquake, an earthquake. I was thinking very fast. I said, it's not construction, it's an earthquake. And while I was running, I told the security guy, call the police, put the alarm so people will, you know, be aware about this.
Yes.
So when my daughter was looking at me, I said, but I'm with my bathrobe. I said, I don't care. Run as fast as much as you can. She was running with her brother towards the exit of the building. And the security guy, he was shocked. He didn't know what to do. I said, call the police. And he said, but what is the address of this building?
He didn't even know.
He didn't know.
He didn't
so
know.
Confused. And I said, 877. I said, no, write for me. And I told my son, fast, write for him. And he wrote. And we ran out of the building. And I told my kids, run as fast as you can, crossing the street. We crossed Collins. We just crossed Collins. God watch us. God was waiting for us to leave.
Okay. So, yeah, when it collapsed. It didn't just cross Collins. It's a little bit different. She's compressing time at that point. But that video content, guys, you can find it right here. Sarah, the name's right here. So now we see that I wanted to tie it together for you now. I think we have, because we need her to go to the lobby, right, to have a reason why she's here to all fall. Plus, we need 611 to, plenty of people get up to start making phone calls. If we just use her account only, it's at the tail end of the collapse, where we still need the model chick to make a phone call, and we still need other people to get up, blow out candles, get dressed, grab their circuit breakers, turn off their lights, and leave the property and walk down some stairs. So we just can't have that happening right then. Besides that, their floor is still in place. So remember, the timeline of the floor is 118. At 122, it goes down. So at 118, she films the floor. The floor already collapsed. Took a second to get her camera going, figure out where it was perhaps, and filmed. When she filmed the whole building, and she realized that her eyes could probably see that the water inside. She zoomed in on the water, not knowing that she's zooming in on the floor falling. It fell at a 111. I believe that 111 are collapsed now. We have structural integrity problems that we can lead clearly from these samples. Clearly from these samples, we can get there from here. So let me move this out of the way. So we've got these BMAs. We have the sample. We have the deteriorated materials. These BMAs are these BMA type are all shit. Now let me get you the supports of the beam. Okay, let me come over here to the left. It might be faster. I might have to go back. I'm looking for the supports right here. So this is the supports of those sisters, those two BMAs. Now I can try to extrapolate, but the scaffolding was just done could be stretched in software and things like that. These two little ladies are side by side. This is single. This is where repair was going to go, and that's also critical share area that we're talking about there. So there's plenty of failures that were already identified for this deck to collapse. Plenty of failures. IMO, in my opinion, pretty obvious. So what I want to show you this, going back to this. So we have two of them together, those supports. Are they this one and this one, and then they're going to fix this BMA here, and also it would have to be supported while they're fixing it. So is this it? And then support the deck that leads up to it. So we're looking at the three of them together. Well, they present as the same height, but the architect, engineer rather, leaves location. He's not specific on this location, just not specific, but we only know of these type BMAs over there. All right, so now we have multiple decks. Remember this again. This is the pool deck and the garage deck are the same level. All right, so that's the same level. This is not of the same level. This steps up to 12'9", which would still step up to 12'9", but you would lose only 11-inch step up. That puts us in this, again, multiple decks here and here. This is where our other flower, this is important because this is where we have the flower pots that present as level. So that shows you that's a separate deck area that when it went down, here's our shear plane, right? And this is what every materials came and collapsed in here. But here's our shear plane created, and that went down together on its own little separate deck, elevated at 12.9, elevated at, so 1 foot greater than this deck. Now over here again, we have the samples. This shows defective, and let's do that, and let's wrap up the video with this again, because this is. I mean, it took me a long time to get you guys here, but hopefully you'll understand. So don't follow any of those engineers that tell you that they ran calculations. What's, I mean, couple of you are in the medical field. If I bring you a broken bone, a fractured leg, how much weight can I lift on that fractured leg? Just tell me, how much can you calculate I can lift? You would tell me, well, nothing until it heals. You should be limping on it. So I wouldn't give you any load ability. I would say you're going to limp, and possibly die of gangrene if you don't get it fixed. And you're going to set it, and it's going to take 6 weeks to heal, 6 weeks, and then we'll go back and revisit how much the muscle atrophy that you have. Marriage is broken up. It's been shearing, running across each other for a long time. Now, it looks like it might have been a piece of steel, but it's been rubbing against each other, moving up and down. This location right here is right here by the car garage. It's been cycling its ass off, as I talked to you about cycling. It's been cycling disgustingly so. There is what it looks. There's a core sample, how beautiful it is internally. I love to see so C, up here. That is that's up there. So that's interesting. Where's the core sample? Oh, there's a core sample there. Oh shit. Yes. The whole deck is just shit. This is coming into the driveway area there. Look at that. Look at that one. Okay, let's see how they present, how they fail in similarities. So we got a 2-inch break, and then we have, let's call it 8.5, and then 10.5. 2, 8.5, and then 10.5. 2, 8, and then 10.5. Really? I'm trying to zoom out. So then let's look at this one. Nope. Let's zoom back out. Really? I'm waiting for it to catch up. 2, 8.5, and 10.5. Really? I'm waiting for it to catch up. I really need to step my game up on this computer programming stuff, don't I? So this one is here. That one's there. Nowhere near it. Oh, that's a pun on words, isn't it? So that one's dissected itself. What did I talk to you guys about? What did I tell you about steel? You show me the steel, I'll show you a control joint. I tell you that steel acts as a control joint. I've stated this numerous times, pissed off a lot of engineers on it. The steel is not just a reinforcement, but it's also a control joint where a fracture, thereupon a fracture is created. There's the steel, there's the fracture. There's the steel, there's the fracture. This one's right above that steel there. One thing I love some crack. I love me some crack. All right, there's the steel, there's the fracture. Love cracks. All right, so test probe A over yonder, way over there by the, oh, no, this is just a line running through it. It is right here. It's right here. Approximate section line. Okay, so again, very interesting that they took out, okay, there's 11 inches. Remember I said about it was 1 foot 11, and then we take off the 1 inch elevation, and there's your 11 inches because the deck came up 1 foot. So there it is. Core A, right about there. And we got all these fractured materials. I'm going to end the video because I think this is very profound for you to just enjoy it. This is the deck right in front of it. So M is right about, what the hell is this? Right about his plywood. Is that the waterproofing for the underneath the tile for the whatever it is? But that's one ugly hole. If that was the hole, I've seen this ugly hole before over there. I saw a clean hole. Why do we get these shitty holes here? I mean, I'm thinking they're getting below the bedding material, but that bedding material looks like that's about it right there. So what is this crap? You know, what is this? What is this? I saw it. I saw it over here too. It drives me crazy. Let me show it to you. That shitty hole. What I did it here also. This is over by the right there, that shear plane issue, right where the car would park. And I don't get. I'm trying to zoom in. I don't get that. Wow, that looks that's very intriguing. Oh, it's the stamped concrete on top right here. Pretty damn thick. But, oh, this is before they dig the core. It's the photograph before they took the core. And then they took the core. And that stamped concrete, they did a cobblestone look. I'll tell you what, it looks pretty nice. Pretty nice. Nice cobblestone look. I've got a few stamps. With wire mesh reinforcement, no waterproofing, 10 1/4 inch thick structural slab. Okay, 10 1/4 inch thick structural slab. How can you call that 10 1/4 inch structural? How can you even call that structural slab? You would just say, you know, 10 and. I find this, guys. Look, would you walk across something like that? Let me ask you that. Would you walk? So I got to be fair. So I use you as the public. Would you walk, if you could see this all broken up like this, would you walk across that? And it was a drop below. Would you walk across it? Now, would you drive your car across that had you seen that? Now, why is this being used, this thing being used as a parking area if it looks like this? Why? Why wasn't it load restricted? I don't get why it wasn't load restricted. I think there's some money to be made there. I think there's some money to be made there. You know what I'm trying to hint at? You guys, you finish off the rest of my words because, you know, I can't be caught on that in the wrong word with the wrong wording. But you figure out what I mean. And this deck here, you know, the car restrictions. I mean, that's our breakaway. Now I'm going to show you in future videos how these interact together. I'm going to get 1, 2, 3, 4 layers, and I'm going to show you what happens when I push down on the top layer. So grab 4 pieces of paper, for example, lay it there, push down on it, and look at the outside edges of that paper and see how they react, because each one of these, as they're loading, are going to start acting differently. That's at the car area. In the deck area, they will be, you know, the 40-pound live load, you're walking on it. I'm not going to count that as creating any more issues, but it's already an issue. This is fractured way over to here, all fractured up right at the what? Critical shear area, right? It's right about there. There's a critical shear area transforming over here and here. This is where it transfers over to the critical shear area right here. That rebar is right about upon the critical shear area. The 16.5s coming there, and then going down there the 10.4s, which is awesome because we know it's 10.4s, and this says it's 12.4s. These are 1/2 inch steel, and this is 5/8 inch steel. We would be, if we can use a tape measure on this, we would be able to see which steel it is. Oops, wrong one. We would be able to see which steel, really, what steel it is, and we'll be able to tell you which section it is. That looks, I'm going to guess that's the 5/8 steel. Ah, not that far. It's too far out. It's too far out. That's damn near 1/3 out. So 1/3 out, I'm going to not go that far. I'm going to 1/3 out. I'm looking at it. 1/3 right about there. 1/3, I'm going to say. You know what? I think 1/3 is a great choice. See right here in line with this one? Then I'll move it over. Well, I'll put it back there at 1/3. So that's about 1/3. Grab it. Yep. Dot. Dot. I'd say it's about 1/3. So with this one, let's do the 1/3 here. Let's have it at 1/3 location. So I'll just pop up one, and let's just do the 1/3. Let's go. Say right about there. That's that dot. 2. That puts me right about there. A little much. So I'll split the difference a little bit. So 1, 2, it's just before the dot. Not enough. Okay, just before the dot. 2, 3. 1/3. So that's 1/3. So 1/3, it puts it out of the critical shear zone. There's a critical shear zone right here with this extra steel. So this puts us in the. Now that might go all the way across. It might be 16 5s. Might go all the way across. Right here, these 16 number 5s and 10 number 4s here. So we would have a 90-degree steel inside that sample. If they hit the steel crosses each other. So we should look at this sample and see a 90-degree metal top to bottom. So we go back to, where is it? Let's go back to the sample and see if we get a 90-degree rotation. Shit, I see there. So 90 would be down here. I can't see it. Hit the steel. Steel would have crossed it. Now I'll get a 90 on the other one, right? Don't I get a 90 on? Let me zoom out a little bit. Don't I get a 90 on the other one? Over here on maybe the parking garage. Kind of move over. It looks like steel was in there. That little hole. I saw 2 pieces of steel in one of the samples. So let's go find it. Let's hunt that extra piece of steel. That's what the core sample looks like. Real nice, smooth holes. There's our steel. It's not quite 90. It looks more parallel than anything. 2 layers going in the same direction, just a little bit of rotation on it. Nothing to cry right home to mama about. That's nice and tight. So this steel it's a lot of friction there. It broke apart. This steel is engaged, married, solid right there. But it took this part is what it engaged with. This part took a grinding, like teeth. Ah, that's disgusting, but it's like teeth grinding apart. And that's interesting, a smooth section there. But it just ground apart. You can see how nice the steel looks there. You see the profile of the rib there. And this just ground apart. It's just junk. That's a lot of deflection that took place. it deflected. This part's deflecting, rubbing, and knocking this part off. Down here, there's like teeth rubbing against each other. This is quite disgusting. An amazing find, of course. I've been waiting to get us there. Now I got us there through through the BMAs. Yes, BMAs, not BMA. Nibbler. Anyway, let me scroll over to your left. Let's end the video with that. So now I got you there. I got you into the garage. Now I got to do models to get you in there, right? I got to do a bunch of models to get you inside. You have to accept the data as it is. You can go over this video multiple times to get it in your coconut, and then I'll do the grinding model thing for you here. Take care, guys. Oh, please, I know it's a long video, but please watch the commercials for me. I think it might help. Comment, of course. Tell me what the commercial is, and that's about it. I want to joke around with Amy. I expect Amy to have quite a few Amy questions. And Mary, I expect you to have a couple too. Who else can I mess with? All right, that's all I can mess with. I'm not a mess. Oh, Jim, of course, a shout out to Jim. Again, a shout out to everybody who, and I love you guys. You know, you supported me by commenting, but really the people who send me money, that's really awesome. I'm almost there, you know, not almost. You know, the money's going towards a better computer, and we'll be more amped up for the next round. A friend of mine's already looked into it. He told me something about like a gamer computer basically to do the software to what I needed to do. But we're still going to not get away from cardboard models. But I need better software for this crap. All right, but I don't want to go away on a Mac. That's my problem. All right, take care, because I got too much vested in the software over here. Goodbye, folks. Love you all. Have fun. Hope this was enlightening. We now have our proof positive. Oh, I can't resist enough to say. I can't resist. I say, please stop following those engineers that tell you they're forensic engineers, that they're professional engineers. Look, they do testing nowadays, as you guys don't know. You can test, you get your PE license. You go to exam schools to learn how to pass the test. It's like a driver's ed class. You know the test already, so when you go there, you already know the questions. Same thing here. If they tell you they ran calculations, that means they have no idea how the real world works. This is going to have its own behavior. There's no reason to run a calculation. We're talking about real life here. This thing lasted 40 years. The problem was the car loading. Shouldn't have been out there. It was at 40 pounds per square foot. That sort of eliminates cars to me when you talk about curb pressure I talked about with you guys. All right. So, love you all. Hang in there. Do what's bad. And if you're going to, like I always tell people, if you're going to be bad, be the best bad you can be. Be the best bad you can be. Be the best at it.